we're going to be solving this system of two equations by elimination. Okay. And for elimination, well, remember substitution, you want isolation. But for elimination, you want the same form. Okay, so same order, x, y, and then a constant, x, y, and then a constant. And then you want additive inverses. Well, let's line these up. 2x plus 3y equals 13. And then negative 4x plus 2y equals negative 2. Now, we don't have additive inverses. So what we're going to do is we're going to create additive inverses. And additive inverses, again, you need one to be positive, one to be other to be negative, and then have the same number. Well, here we do have a positive and a negative, so this has half of what we need. We just need these two numbers to be the same. So the least common multiple for the 2 and 4 would be 4. So if both of these were 4, we could actually make this work. So what I'm going to do is I'm going to take this term here and multiply everything by 2. Okay, so this will change this into a 4x plus 6y equals 26, and this will remain negative 4x plus 2y equals negative 2. And now you see they have additive inverses. So we can go ahead and combine both equations. So these will eliminate, and this will give me 8y. This will give me 24. Then we'll divide both sides by 8. And we'll get 1y is equal to 3. Okay, that solves the y. Now for the x, to solve for x, we're going to use one of these two equations. Let's use the, in fact, we can choose any one of these, but I'm going to choose this one. This is the nicest one, I think. No negatives in there. So I'm going to choose the 2x plus 3y equal to 13. And I'm going to substitute the y here for 3. So it becomes 2x plus 3 times 3 equals 13. That becomes 2x plus 9 equals 13. Subtract 9 from both sides. We end up with 2x equals 4. And divide by 2, divide by 2, we get 1x equals 2. Oh, sorry, couldn't see that. Okay, so once again, we get 2x plus 3y equals 13. We substitute the y for 3, so we get 2x plus 3 times 3 equals 13. That becomes 2x plus 9 equals 13. Subtract 9 from both sides. That gives us 2x equals 4. Divide 2x by 2, divide by 4 by 2, you'll get 1x is equal to 2. This means the solution of our system is going to be x is 2 and y is going to be 3. Okay, let's try that again. Alright, what we have here is a 3x plus 6y equals a negative 3, and a 4x minus 4y equals 20. Okay, now we're looking for same form, and we have same form xy constant, and then we need additive inverses. Additive inverses, we need a negative and a positive. Well, here's a negative and positive combination right here, but the numbers are different. That's the 6 and 4. So I need the least common multiple for 6 and 4, and that would be a 12. Okay, so I need to turn the 6 into a 12 and the negative 4 into a negative 12. So I'm going to multiply the top one by 2. That'll create a 12. And I'll multiply the bottom one here by a positive 3. That'll create a negative 12. So let's multiply everything and see what we get. We get a 6x plus 12y and a negative 6. The second one, we get a 12x, a negative 12y, and a positive 60. Okay, so Let's now combine these two. This will become an 18x. This eliminates. And this becomes a 54. Okay. Now let's divide everything by 18 to get the 1x. We get 1x equals, I think that's 3. Yeah, that's 3. So x is 3. Now, let's choose an equation. We actually have several to choose from. We have the 3x plus 6y equals -3, the 4x minus 4y equals 20, the 6x plus 12y equals -6, and the 12x plus minus 12y equals 60. I think this one is the least complicated, so I'm going to choose this one for substitution. So let's go with the 3x plus 6y equals -3, and we're going to substitute the x for 3. So this becomes 3 times 3 plus 6y equals -3. This becomes a 9 plus 6y equals -3. And then we're going to subtract 9 from both sides. That's going to give us a 6y equals -12. And we'll divide both sides by 6. I'm running out of room. Let's see if I can get some more room here. Okay, a little more room. We'll get 1y equals -2. So our conclusion is that the solution of this system will be x is 3 and y is -2.